generally with simplifying an algebraic expression, it usually tends to mean no negative exponents, combining any like terms where you can, but it can also mean factored. So we're going to review factoring in a little more depth in the next section, section 8.4. But we're going to first just review the most basic way of factoring, and that is by taking out the greatest common factor. So factoring can be thought of as, writing something as a product. So for example, 20 can be rewritten as 5 times 4. So that's one way of factoring 20. It can be also thought of as the opposite of the distributive property, especially when you have something that has more than one term in it. So the distributive property goes like this, right? So here we have a connection between multiplication and addition or subtraction. It just says that, if you are multiplying something, in this case I've got A, times a sum of two different things, then you're really multiplying each of those things by A. So we have to multiply the B times A, so we get AB, and then also the C times A, so plus AC. Factoring out the greatest common factor can be kind of visualized as going the opposite way. So we're looking for, the A that's in common between these two parts that are separated across plus or minus, and taking that out and writing again as a product or factoring. So let's look at a few examples here with factoring out the GCF, which again, right, this is the greatest common factor. So the first example that we have is 2x squared minus 4x to the fifth. So when you're looking at factoring powers of x that are separated over plus and minus, no matter how many terms that there are, so this one just has two terms, this one and this one, and no matter how many terms that are in the expression, you can look at the numbers separately and then also the powers of x, or the powers of like bases. So we have 2 and we have 4. So the largest thing that goes into both 2 and 4, the greatest common factor of both 2 and 4, is going to be 2. So we're going to write this equivalently by factoring out the GCF, and part of the GCF is going to be 2. Then we can look at the powers of x. So we have x to the second, and then we have x to the fifth. The greatest power of x that goes into both of those things is x squared. But even though x to the fifth is the greatest power, the one that is a common factor between each of these things is really the lowest power of x that is present. So here, okay, this is our GCF. Now we have to figure out what's left over. So in other words, like this was the A that was present in both of these two terms. We have to find what's left over, finding the B and the C. So this can be thought of as dividing, because we're not multiplying, right? With distributing, we're multiplying. Here we're kind of dividing out the 2x squared. So if you think about dividing 2x squared by the GCF of 2x squared, okay, when you divide 2x squared by 2x squared, that gives you 1. So here we have a 1 left over. Then we, our sign here was a minus, and then we think about what happens when we divide 4x to the fifth by 2x squared. Okay, 4 divided by 2 is 2. Okay, so we've got 2 here. Then x to the fifth divided by x squared, we would end up subtracting the power. So this will be to the 5 minus 2, or to the third power. And there we go. Here is the simplified version that we got by factoring out the greatest common factor. You can always check if your work was good by just redistributing in your GCF into both of these pieces and seeing if you get what you started with. Okay, I hope that was basic enough. This should be relatively straightforward for you. If you're really struggling with this, come talk to me and we can see if there may be some other options that we can have for you. Example number 2 is 3x to the 1/2 power minus 9x to the 5/2 power. Now you might see this and be a little freaked out by the fractions in the power. Don't worry, it is the same process as the example that we just did. Same exact thing. So we want to look at the numbers first, or separately from the powers of x. We've got 3 and 9. All right, so the largest the largest factor of 3 and 9 that's present in both is 3. So that's part of our GCF. Let's see, so here's going to be our greatest common factor. Then we look at the things that have like bases. So here we have x to the 1/2 and x to the 5/2. Okay, the largest exponent that can be taken out or factored out of both of those powers of x, again, is still the smallest power of x. So this will just be x to the 1/2. And now, the harder part is often figuring out what's left over. Okay, so just like before, here we factored out, like this first term was our GCF, so we're gonna think about dividing 3x to the 1/2 by 3x to the 1/2. That just cancels, and when you cancel by division, you get 1, right, not 0, so make sure that you have that 1 there. Then we think about dividing 9x to the 5/2 by 3x to the 1/2. Okay, 9 divided by 3 gives us 3. And then we have 5/2 in the exponent in the numerator. So again, we're thinking of dividing here. So we have these powers of x that are divided. So we're going to end up subtracting the powers. So we're going to have 5/2 minus 1/2. Okay, and that is 4/2. And so that's the second power. So this will end up being 3x squared in that second part. And here we go. Here, this is factored. We took out the GCF, and so this is a simplified version found by factoring. Again, optionally, if you want, you can rewrite this as radical x. It's totally up to you. As long as there are no negative exponents in your simplified version, then it's pretty much fully simplified. Okay, example 3. We have 2x to the negative 1/2 plus 3x to the positive 5/2. Trying to add on little layers at once. So here we're just looking at, okay, what do you do when you have a negative exponent? And the answer is the same exact thing. The same exact thing. So we're going to look at the numbers first. We've got 2 and we've got 3. No factors in common there. So no number is going to come out with the GCF. Then we also look at the power of x here and the power of x here. Come on, iPad. It's still having a Monday. Oh. Well, okay. So we are going to take out the power of x that is present in both. And I know it's a little weird to think about, but can you just kind of follow the rule that it's the smallest power of x that's present? Now, negative 1/2 is smaller than 5/2. And so we're going to take out x to the negative 1/2 power. Okay, so this is right here our GCF. Now, dividing out or factoring out an x to the negative 1/2, right, we're going to have just a 2 left over in the first part. Okay, dividing out an x to the negative 1/2 in the second part will leave us with, oh, still happening. I don't know what's up with, it's really struggling with this red highlighter here. Okay, so dividing out x to the negative 1/2, oh, there we go. In that second term, we will still have the 3. We're still going to subtract the powers. So really we're going to have, like 5/2 minus negative 1/2. Okay, when we subtract a negative, we end up adding it. Okay, so this will be like plus and plus. So we'll have 5/2 plus 1/2, that is 6/2, and that is otherwise known as 3. So here the exponent on the x in the second term, if we factor out the x to the negative 1/2, will be x to the third power. Okay, now in this case, we do have a negative power, so we can rewrite this without the negative exponent by converting to a fraction. Okay, right here we have multiply. So multiply by something to a negative power. This is going to change to divide, and this x to the negative 1/2 will go down into the denominator. become x to the positive 1/2. And the rest of the expression here is going to stay up in the numerator. So 2 plus 3x cubed will be now instead divided by x to the positive 1/2. And there we go. It's fully simplified. Again, if you want to rewrite that x to the 1/2 as a square root, that is totally fine. But I don't know, this way is enough. Okay, I've got 3 more examples here of simplifying using the greatest common factor. And the fourth one is we would call a rational expression. So it has some powers of x up top, some powers of x in the bottom. It's kind of like a fraction with x's. So this is a rational expression. 3x squared plus x to the 4th over x. Now some of you might look at this and really want to cancel out this x here with maybe like one of them here. It's really tempting. And I want you to be really conscious of your desires to do that throughout the semester, because it will never ever get you to the right place. Okay, so this is like a fatal error, like a very illegal thing to do in math, is to cancel out division over plus, right? So like we're dividing basically 3x squared by x, and we're dividing x to the 4th by x. So if you go canceling this here with one of the ones in this part, you're forgetting all about this x to the 4th, and it's kind of rude. So a safe way to go about this is to only cancel with things in the denominator if you can factor out something that would cancel from the numerator. Okay, so maybe we should actually make a note of that. So we can only cancel in the denominator if, and this is not like very carefully worded, only cancel in the denominator if it can be factored out of the numerator. So you'll see what I mean as I show you the safest way to go about canceling this x here. Okay, so in the numerator, we're going to like factor this. So in the bottom, there's nothing to do with the factoring. The x is just x. But in the numerator, we can actually factor out a greatest common factor of x squared. And when we do that, we're going to be left with 3 plus x squared. Okay, now here we have multiply, and then we have divide, right? And these are indeed opposite operations. So you can cancel now this x with one of the x's from the x squared. Okay, and now what we're left with here will be x times 3 plus x squared. And here is our simplified form. Okay, example number 5, ramping up in difficulty. Don't even look at example number 6 yet. We'll get there when we get there. Okay, example number 5, we've got 3/5 times x plus 1 to the 5/3 plus 3/4 times x plus 1 to the 8/3. And there's a couple things that are sort of different and maybe a little intimidating here. And one of those things is that we have these coefficients that are fractions. Okay. Another thing is that we have these, instead of x to the 5/3, we've got x plus 1 to the 5/3, right? Same thing over here. Instead of x to the 8/3, we've got x plus 1 to the 8/3. You might think that this introduces a lot more complexity, but really it doesn't. We have a number times variable stuff to a power, plus another number times the same variable stuff to a different power. It's actually very similar in structure to example number 1, 2, 3, even the numerator of 4. So you want to look at what's in common. So we're looking for, let's see, a GCF here. First you look at, so this is the plus that we're looking across. Okay, we have this piece and this piece. And we want to find what's in common with the number. So we've got 3/5 and we've got 3/4. So is there a common like factor or like a common number that we could divide out from 3/5 and 3/4. And the short answer is, we can look at this 3/5 as 3 times 1/5. And we can look at 3/4 as 3 times 1/4. And so we can factor out a 3 because it's in both of the numerators. If it were, like 5/3 and 4/3, we could factor out a 1/3 because the denominators would be the same. Okay, here we have the same base, 2 different powers. So again, the GCF is going to have that same base factored out to the smallest power that occurs, and that's to the 5/3. We're going to factor out an x plus 1 to the 5/3. Okay, what we've got left over here, we're going to have 1/5 left over. Now that's kind of hard for you to see. I mean, I just think about, well, if we distributed the 3 into here, we would multiply 3 times 1/5, and that will give us 3/5. We factored out all of this, so that's just 1/5 in the first part. Then we have plus. Okay, now similarly, when we factor out a 3 out of 3/4, we're going to get just 1/4. Okay, here, think about dividing this by x plus 1 to the 5/3. Right, and so we're going to subtract these powers here. 8/3 minus 4/3. So let's just see, 8/3, 5/3. I think I said 4/3. 8 minus 5 is 3. 3 over 3 gives us 1. Okay, so this is x plus 1 to the first. All right, so in general, and we haven't really had to think about this up to now, whenever you take out the GCF, you want to look at what remains or what it's multiplied by and see, can you simplify this further? And if you look at that and you're like, I don't want to deal with it anymore because there's fractions there. I mean, just think, can you maybe combine like terms together, right? So, okay, like can this be simplified? Sometimes that means expanding, which in this case, kind of just look at distributing the 1/4 here and here, then we'll be able to combine the numerical terms of 1/5 and 1/4 together. Okay, so that's something else that I would do. So we're going to leave the GCF the same. Let's distribute the 1/4 into the parentheses. We'll get 1/4 x plus 1/4. Okay, then we have 1/5 and 1/4 that are numbers that could be added together. You could do it with some scratch work by getting a common denominator, or you can have your calculator do this for you. Generally, we do want to use fractions, so this will end up being 9 over 20. And we've got plus 1/4 x. I would say this is pretty simplified, so we can leave it like this. Again, optionally, if you want, you could put this in radical form, but it is fine with its rational exponent. Okay, I think we're ready to tackle example number 6. Now, on first glance, this expression looks pretty crazy. We have 3 times x plus 2 squared times x minus 1 to the third. Then that is minus 3 times x plus 2 cubed times x minus 1 squared. And that is all divided by x minus 1 cubed squared. Now we are going to eventually be calculating something called a derivative. That's like the huge topic in Calculus 1. And this expression is actually the result of calculating the derivative of a certain function. So at some point, we are going to find the derivative of a function. Then it's going to look like this. Then we are going to want to simplify it because we want to use it to give us some information about the function. Okay, so we're just going to practice what would you do in a case like this, because it can be kind of overwhelming. Again, many different things you could do first. I might say, well, here, I don't like that. Like there's too many parentheses and stuff. So why not just you know, we've got something to a power, so we're going to multiply those powers together. So let's just leave. We'll worry about the numerator in just a second. Okay, and then in the bottom, we're just going to write x minus 1, 3 times 2 is 6. All right, now in the bottom, and even in the top, you never want to, I mean, I don't know if anyone would think to do this, but the idea would never be to, you know, like expand this, like FOIL this, and then multiply this out and do the same thing here and do the same thing here. Like that's never, generally speaking, most of the time won't help a situation. But if you consider the numerator, looking here and here, okay, we have a product of 3 things minus another product of 3 things. There's a lot of stuff in common. Okay, like if you look numerically, we have 3 and 3. If you look at different bases, we have x plus 2 and x plus 2. And then we have x minus 1 and x minus 1. So there's going to be a greatest common factor that we can take out of the numerator. So let's do that. Let's leave the denominator the same. Okay, and we're going to want to look for a GCF across, you know, we've got this box or this oval and that second oval. So we can definitely take out a 3. Then we look at the x plus 2, with the highest power that we could take out of both is squared. Then we look at x minus 1, and the highest power that we could take out of both, again, is squared. Okay, so again, here is the GCF of the numerator. Now we have to figure out what's left over. It looks like in the first term, the first chunk here, when we took out the 3, we took out x plus 1 squared, we took out x minus 1 squared, so there's going to be x minus 1 left to the first power. Okay, now we have minus, so that's like this minus right here, okay, minus. Now from the second oval here, we took out 3. Here we factored out x plus 2 squared, so there's going to be an x plus 2 to the first left over. Oops. Now make sure, since this is minus, we need to make sure we're subtracting everything in the x plus 2, so in parentheses here. Okay, if we don't have parentheses, then we're not going to be subtracting the 2, we're just subtracting the x. So make sure that we keep parentheses there if there's ever, you know, plus or minus between 2 things that you're subtracting. Okay, let's just see. So then we had x minus 1 squared, we had x minus 1 squared, so that part's gone too. So just x plus 2 left from that second oval. All right, now we're not quite done, right? We want to keep on going. So like here, after we have factored out the GCF, can we simplify what's left over anymore? And I think we can, right? So if we just distribute the minus sign, we'll be able to combine some like terms together. Okay, so this is going to be x minus 1 minus x, and then minus 2. That's what will be inside of these parentheses here. Now x minus 1 minus x, so we've got x minus x, so those are going to cancel out, and then we have negative 1 minus 2, and so that's negative 3. So that whole thing in those orange parentheses is just actually going to end up being negative 3. All right, then additionally, we actually have now been able to write the numerator as some stuff multiplied by x minus 1 squared. And then we're dividing by x minus 1 to the 6th. So we can also cancel out that whole factor in the numerator and then just get it to the 4th in the denominator. That's really nice, right? That makes things work out pretty nicely. So what do we have? 3 times x plus 2 squared. And then in the orange parentheses here, we had negative 3. And then in the bottom, we have x minus 1 to the fourth. Now 3 times negative 3, I mean, I don't know, I might just, write that as negative 9. But other than that, everything is nice and factored, x plus 2 squared. No need to, expand that out. If something's factored, you generally want to leave it that way, and same thing in the bottom. And I think that you'd agree that this is way nicer than what we began with, right? Like there's no question about that. All right, so in this class, people tend to say that their algebra skills improve. Like that's one of the things that has I've heard a lot from students who have completed this course. So if this, throughout this semester, if you just have a mindset of like, I might need to work a little bit on my algebra, like we will be doing that throughout the whole semester. Okay, so in the next topic of this section, we will talk about finding domain. And so that'll be the last video of section A.3.